Guys, we welcome back to topic of sequences. And before doing that, let's remember several stuff that we gone through in sequence part 1. So actually there was general idea what sequence is. So basically arrange terms in specific order like increasing or decreasing, where you can plug a specific rule in order to find the next element. So before we're gonna go to arithmetic sequence, I want to clarify one thing about how to use general formula if you have UN's terms set up as the formula. For example, let's consider simple case. For UN, we set up the formula 2n plus 1. How to use that and what does it mean? Okay, UN is n's term in your sequence, and n is a counting number, right? So this is counting number. How to use this formula in order to generate a specific sequence that's given with this formula? It's pretty easy. You just need to set up the table with values n and un and just start plugging different numbers, counting numbers for n. Okay, in this case, we have n here in the formula. And what we need to do is just to run your n starting from 1 up to certain number that you're given. Let's say we need to generate 4 terms. So that's why we need to end up with n equals 4. That's running all through natural numbers from 1 to 4. Okay. Just simply plug into the formula. Okay, we have n equals 1. Let's plug into the formula in order to determine the first term of the sequence. So u1 is 2n plus 1, so 2 times 1, n plus 1. Alright, it will generate the value 3. So u2, we plug to in a similar manner. 2 times 2 plus 1. That's how we can get 5. So u3, in the same manner, 2 times 3 plus 1, so we'll get 7. And the last u4 is 2 times 4 plus 1, and that's how we get 9. Alright, we generated sequence, the setup with the formula 2n plus 1. This is what is called algebraic formula for the sequence. So in particular sequence is called arithmetic. We'll have an explanation soon. So let's set up now in a vertical way. So n counting number that's running from 1 up to, let's say, 4. And we have nth term our sequence. So here is u1 that we generate recently. It's 3, 5, 7, and 9. So they're basically values or our elements or terms. All those words can be used interchangeably. Alright, we have a sequence. So remember before you were given several rules how you can determine the following, like several terms, next to terms, for example, if you're given like 3 or 4 terms. Okay, we started exploring the difference between the elements. The difference here is 2, because 5 minus 3 is 2. So let's take the difference between the third and the second element. 7 minus 5 is 2 and 2. So as you can see, the difference is not changing. It stays the same. Whenever you take 2 elements and 2 adjacent elements and try to find the difference between them, it's not changing. It's always 2. Okay, so what does it mean? It means that in order to get, let's say, to the fourth element, starting from the very first one, we can do in the simplest way. Let's put them as stones. So let's put the values as stones here. So that's value 3 is the first stone. That's value 5 the second, and in the same manner. Okay, so the red is used staying on the very first stone that has value 3. In order to get to the fourth stone that is here, how many jumps you need to make? Sorry, how many jumps you need to do in order to get stone number 9, stone number 4 with the value 9? 1, 2, 3. So they split it apart in 3 consecutive jumps. All right. So that's the first stone, second, third, and fourth. All right. In order to get to U4, we basically need to make 3 consecutive jumps. So it means that if you want to calculate the value of fourth term, for example, you need to start from U1 and add 3 jumps, and each jump has a value of 2. All right. Let's calculate how to arrive to U5. Again, you need to start from the very first value, and in this case, you need to do 1 more jump. It means the value that you will have here is going to be 11. This is 5th stone. All right, so that's why you need to do 4 consecutive steps with each value of 2. All right, let's try to generalize this sequence. For example, you skip several steps, and now here is the nth stone somewhere on the way. Again, normally you should start from the first value, 3, that's U1. You need to make how many jumps you need to do in this case. Let's have a look at the values. So U4, 3 jumps. So U5, 4 jumps. So it means the number of jumps that you need to do in order to get, let's say, nth value is just 1 less than this number. So it means n minus 1 because you have a counting number n, so number of jumps should be 1 less than your number. Okay, so that's why it's n minus 1, and times the step length. So remember before we used the name. We use the name for that, for the difference between elements, just difference. All right, so I put D, letter D for the difference. And now if there were a value not 3 but any other, anyway it would be the first term, so I can put the very first term of the sequence. And now we got the formula. All right, so we got the formula how to calculate nth term of the sequence. That's the formula, nth term of the arithmetic sequence. And it's pretty intuitive, clear how it's set up. You just set up as number of steps in order to reach your nth value. So number of steps is always 1 less than your counting number of the elements you want to calculate. I hope that's very clear how it works. Okay, so for example, let's say you're given the formula. Let's have a little practice. You're given several elements in your sequence. Say 7, 10, 13, 16. So please try to give the formula for this particular sequence. All right, pause the video. So just have a reference to the formula, have a reference to understanding how each element was calculated, and try to find the formula for your particular sequence. All right, I hope you did it. It wasn't hard. So your first value is U1, all right? So let's calculate the difference. So if it's not changing, that's definitely arithmetic sequence. And then we can apply this formula. Alright, so let's calculate the difference. So the difference 3 here, 3 here, and 3 here. Alright, it's not changing, so that's great. That's why this sort of sequence is arithmetic. So how can we get un's term? Alright, so we start from the first term, we add n minus 1 step, and each step length is d. Let's just write using our parameters. So u1 is 7, difference is 3, we just directly plug those parameters in our formula. N minus 1 times 3. Okay, but of course you can simplify it. For example, you can expand brackets here and say that it's going to be 3n minus 3, and on top of that you can say that the final formula is 3n plus 4. Okay, so we got the formula, but for example you miscalculated something. How to understand is correct or not? So basically you can say you want to determine the next term with the difference 3 becomes 19, and let's say so this first term, second, third, fourth, fifth term. So let's say you want to determine fifth term using our formula. All right, so fifth term is actually u1 plus dn minus 1. In our case n is 5, or you can directly use your final version. So let's calculate in both ways. So first of all, let's plug in our general formula. So u1, the first term, it was 7, so u1 is 7, difference is 3, 5 minus 1 is 4, now let's see, 3 times 4, 12, so 19. All right, perfect, it works. And let's calculate the final using the final formula. So un, in this case, we want to calculate number 5, u fifth element, and here we just plug 5 instead of n. 15 and 4, 19. All right, that works perfectly. So, well done. We've done topic dedicated to arithmetic sequence. Hope you enjoyed. I can give you a bit more complicated example as the final step to see how we still can use the same approach using arithmetic sequence, but the sequence itself is not arithmetic. Okay, so let's consider a sequence 1 over 8, 1 over 11, 1 over 14. Okay, let's take maybe the next term, 1 over, I guess, 1 over 17. Okay, let's consider this sort of sequence. It's fractional one. If you start calculating the difference, you'll find out that difference is not the same. So, of course, you need to stop yourself and say, okay, this sequence is not arithmetic. But if you pay attention, remember before when we use general idea, we also pay attention to the elements values and trying to figure out maybe another row. But here, as you can see, the top is not changing, so it's always 1. What we can do the following. We can say that if we have a look at denominators and start thinking about difference between them, let's write down denominators and let's try to find the difference between them. We find out that the difference here is 3, the next difference is also 3, and the next difference is also 3. Alright, so looks like denominators in this case behaves like a arithmetic sequence. Arithmetic sequence. Can we apply our general rule for arithmetic sequence to find, let's say, n's denominator? So we skip that and say something is going to be here, because we definitely understand that numerator still be 1. So but we're wondering about what's denominator. Alright, so that's UN's term. And we can say that in order to calculate UN's D denominator, we should start using our formula from U1 n minus 1 times D. Alright, let's calculate using our values. So UN's denominator is actually 8, the first term, number of steps, n minus 1, and times the difference. Okay, let's simplify, and we'll get 3n plus 8 minus 3 becomes plus 5. So that's the general formula for n's denominator, right? So can we plug into, instead of n's term? Yeah, of course. So that's why un's term should have the following formula. All right. So that's a bit more complicated example. However, you need to be able first to recognize which part of the element behaves like an arithmetic sequence, as in this case. So probably another sequence will be probably another type of sequence, staying for denominator, let's say. So I think this topic completely revealed. Hope you enjoy, and there will be a set of questions to you. So in the next video at the very start for yourself practicing. Thank you guys. See you.